Is it recording?
Yeah.
Okay. Today we're going to talk about hooking up a circuit breaker in a panel. We kind of already went over some of this stuff, what's hot, what's not, but I'm just going to do a quick review here. First of all, whenever you're working in a panel, you should shut the main breaker off, which is here. And I have it in the off position, that is on. Okay. When this breaker is off, that does not kill this whole panel. It would still have hot in here, which would be your main wires coming to this lug and this lug here. That whole wire and at these lugs would be hot. When you turn this breaker on, that livens both of these bars up, one for each side, which is 120 volts coming to each one, right? Okay. So, different types of breakers, we kind of already went over this also. Remember, wire sizes matter what size breaker you use. This is a 15 amp single pole breaker. That would be for your normal circuits, lighting, your receptacles, and that's what you guys will be using. Same as working in this panel with this off, you should have this off too. Some people will wire a breaker up with this on, which means this is all live. If that was the case, like you didn't want to shut the whole house down, you definitely would want to make sure this breaker was off as you plug it in. But I am going to shut that off. Other types of breakers, this is a 20 amp breaker. So just a little review. What size wire do you use with a 15 amp breaker? What about a 20 amp breaker? 20 amp breaker is 12 wire, yes. And this is 14 for 15 amp breaker, okay? Then there's also double pull breakers, okay? It pulls off of two legs. It's double the thickness. It pulls off from this leg and this leg, making this 240, right? Okay, same thing. Same operation, shutting it off before you kick on. So I got my breaker off. I am going to plug my breaker in where I want it, which is a 15 amp breaker because we're going to run 14 wire. Every panel or every brand hooks a little bit different. This is Square D Home Line. You hook it on this outside here and then you snap it onto the bar, okay? Once that's snapped in there, if you turn this on and this happened to be on, that screw right back there is also hot. Okay, that's where you're picking your hot up from. I got them both off. So your next thing, we're going to run the wire. I am just going to run it to this receptacle down here. So 15 amp breaker, I am using 14 wire. Now, I'm running a 15 amp circuit. Would this be okay to run 12 wire? Would it be? It would be, because the wire's bigger than what it needs to be. That's okay, but you just can't go down smaller, okay? So normally when you're running wire, the wire running from your panel to the first place it's going to, that's called your home run. That's gonna liven that circuit up, but you're coming to the first box. That box, generally, home runs can be long. They can go from one end of a building to the other where the panel is. You always want it to be the closest box, usually, to the panel. So you're running less of a home run, less wire, okay? And then branch out from there to your other devices. So I'm gonna run it to this. When you run wire into a panel or any metal box, remember, it has to have something to clamp down on the wire. There's holes that you knock out here. You just take a hammer and a screwdriver and you can hit that a little bit, take a pair of pliers, bend it back and forth, it busts off, leaves a hole. Now, by code, you cannot punch these out and leave these open, not have wire run in them. If you accidentally punched out a wrong one or you didn't use it, you can buy plugs to fill these, but you can't just leave them open. But we're going to use what's called a Romex connector. The wire cannot just run through that hole. It has to run through a device that tightens down on the wire. going into a metal box. Otherwise, that wire could work back and forth and it could cut the wire. Okay, so that just has a nut, screws to the outside. You tighten this down. Now, a couple different ways you can do this. You can grab onto this with a pair of pliers to tighten it down. These have ears on them. You can take your screwdriver and get on one of those ears and hit this with your screwdriver or a hammer, and it'll tighten that Romex connector down, but that has to be fairly snug. So I got my Romex connector in there. I'm going to run my wire. Now, I'm going to run this wire up in here. General rule of thumb when you're running wire in a panel, you want to leave it, if you're coming from the bottom of the panel, usually a foot or so past the panel on the opposite side. If you were coming from the top down, it would be the same thing down here. You have to leave that much wire, and you'll see that a little bit later. So I'm going to tighten this Romex connector down so that doesn't move on me. Okay, so we've dealt with stapling in the book for plastic boxes, but a lot of you, as you read through, how far away can you staple, or do you have to staple no farther than from a metal box? A lot of you have read this when you've looked over your stapling. Does anybody remember? So what is it from a plastic box? How far is the most you can be away? 6 inches. A metal box, because you have to have some kind of connector that hooks it at there, you can staple up to 10 inches away from a metal box. So it's a little bit different. Now, it could be 9, 8, 7. It can be less. It just can't be any more than 10. So I'm going to run this down here and trying to gauge about what I need. I need 6 inches sticking out after it's stapled, correct? Minimum. So I'm going to cut that off there. I'm going to run this in this box. I'm not going to get too concerned with this end and hooking this up. We've already been through that. But I do want to go over the stapling. So I can be up to 10 inches. I like to stay under, like we talked about before. So I'm going to stay within 6 inches of this box. In the center of the stud, correct? Studs are hard. Being careful not to nick your wire. Okay, so I have that in there. So you've got all this wire here, okay? What did you have to leave inside a plastic box for the coating where you started stripping?
6 inches? Was it 1.5?
Inch and a half of that paper left on there, correct? So you want to do the same thing in here. Don't leave a bunch of this coating on here. You want to strip that. So you're taking most of that outside coating off. So you get all that outside coating off, leaving inch and a half of that, pulling your paper off. Okay, so this panel does not have a hot run into it, but we're going to treat it as it does, and we will liven these up when you guys test your 3-ways. What do you think you have to worry about the most right here?
Them touching.
Which one would be the most dangerous to touch, I guess? I mean, if I pulled this in here and I happen to touch this plastic to that, is that going to hurt anything?
The copper one.
Yeah, the bare one. That's where you want to start, okay? You always want to get rid of this copper, get it hooked up so it's not going to take a chance. Because you start pulling around on these wires, you might flick this up into there and then get to a hot, okay? So you want to get rid of that first. So you want to do this nice and neat. And if a panel starts out neat, I don't know if any of you have ever taken a cover off your panel at your house. How neat does it look in there? And would that be hard to track a wire down? Okay, so today they get really fussy about this. They want to see them neat. So wherever you're coming in at, if you're going to the breaker on this side, you generally want to keep your stuff to this side. You bend that right back as far back as you can, nice and flat. Everything in nice square angles. You're going to run it up. Now your ground and your neutral hook to these bars here, or here, okay? So once you get up, you want to start right at the top if you're keeping your wires neat. So I want to hook to that first screw. So I just kind of guess what that is. I've made a nice little square bend here. This isn't coming up at an angle like this. You got to stay flat. So I'm kind of gauging where I want to cut that off. I'm going to cut that off. Now one thing, when you're pulling on this and then you cut it, you got to watch that don't fling back in there and touch something you don't want it to touch. So once you have it cut, you're going to hook that up. That's okay. We can't stop. So you're going to hook that underneath that screw, and it's a set screw that'll clamp right down on it. Now if you look through here, you can see your wire go all the way through. You can take it all the way till it hits this plastic right here. That way you know what's in there. And you tighten that down. You want to make sure you tighten that good. Now, when you're working in a panel, this protects you. You don't want to be grabbing up here and then trying to tighten down to steady yourself. Keep your fingers back where you're protected on the handle of the screwdriver. Okay, tighten that down good. You always want to pull on them and make sure they're in there good. And then you can straighten this out a little bit more after you've got that hooked up. Okay, so next would be your white, your neutral. Now, if this is a panel in your house, grounds and neutrals can hook to the same bar, okay? They cannot be underneath the same screw, okay? So you got to go to the next screw down. Now, if this was a sub panel in your garage, grounds have to stay on one side, neutrals on the other. And what I'm saying by a sub panel, or this could be in your house if you have more than one panel. The main panel is the one that the power comes in from outside, from Consumers or Detroit Edison or whatever it comes from. That's your main panel. That's where your grounds and neutrals can be on the same bar. So grounds and neutrals can be over here and here at the same time. It doesn't matter. But once you jump from this panel using a breaker to another panel, maybe in your garage or a pole barn or whatever it may be, then they have to be separated. Grounds on one side, neutrals on the other, okay? Has to be that way by code. So same process, you're just gonna bend this back right with that wire. You're gonna run it up here, figure out where it needs to hook, square it off, and then calculate about how much you need to cut. Cut it off, strip it. Now, same way with this is what you did on your receptacles or in your plug. When you stick this in here, you got to make sure that you do not have plastic going underneath that screw, okay? Because it won't make contact, or it will at first, and then later on it may not. So same thing, you can push it through till it hits that plastic. Now you don't want to see a bunch of this stripped past this point, but you do want to see a little bit of copper there, knowing that you don't have plastic underneath there. So we'll tighten that down. Screwdriver don't fit that good. Okay. Same thing, straighten it out. You can pull around on it a little bit, making sure it's in there nice and tight, and that you don't have any plastic. So then the last thing that you would want to do is your hot wire. Same process. You're going to bend it flat back there, bring it up. Now this is going to go to the breaker, that screw on the breaker. So this one will bend a little bit lower, and it's going to come out like that. Cut off point. Keep losing my pliers. Strippers rather. Same thing, if you strip about that 3/4, you're usually pretty good with the amount you want to strip off. Stripping more is gonna make it so a bunch of that copper is exposed. So you opening this up, slips behind, there's a little plate there that it slips behind, and it can go top or bottom.
Have you done it both ways?
What's that?
Like, instead of, like, head it off first, take the box up, then put the wire on, then...
Then snap that on. Well, it's really, that would be really hard to gauge how long your wire needed to be. If you don't have your breaker snapped in, I suppose you could do it that way, but it's hard to judge. So same thing, you can straighten this wire up where you want it, make sure it looks nice and square, and making sure this is in there tight, and making sure you don't have copper strip past this plastic point here of the breaker. So once you've got that completed, then you're able to turn your main breaker back on, turn that on, should liven your circuit up, okay? Pretty simple. A 240 breaker, where'd I do with them other breakers? Right up here. These work the same. The only difference with these is they have two hots, okay? 110 from each side. Now remember, when this snaps on here, it snaps on pulling off this lug, which is this bar, and this lug, which is this bar. So it's picking up 120 from each side, and that's how come it's 240. That would be for hot water heaters, air conditioners, that kind of stuff. So any questions? No questions. So that's pretty much all there is. You guys should be able to complete your 3-way now with that information. Good enough.
Smile.